Welcome to the deep dive. Today, we're embarking on a really fascinating journey through a stack of sources that give us this panoramic view of the AI landscape right now.
Yeah, it's quite a collection. We've got stuff on how AI is being built, the real world impact of actually powering these systems.
Right, the physical side.
Exactly. And then the huge challenge of, well, governing them globally.
So our mission for this deep dive really is to pull out the most important nuggets from all these different perspectives. We
Yeah.
want to help you connect the dots between, the cutting edge development, the sometimes surprising environmental footprint.
Which is getting more attention now.
Definitely. And the crucial legislative efforts trying to keep pace. So we'll explore what's making AI smarter, what it actually takes resource-wise to run these powerful models, and how the world is trying to sort of set the rules for this incredibly rapid evolution.
What's really striking, I think, is just how interconnected these areas are, even though they might seem separate at first glance. So on one hand, you see this incredible progress, AI tackling complex problems almost autonomously now. But then that progress, it comes with tangible resource demands, right?
Yeah.
Which then fuels this urgent push for robust governance, making sure it's all developed responsibly.
Yeah.
So we'll unpack each layer, show how they fit.
Okay, let's kick things off then with some pretty exciting developments in AI itself. First up, we have Replit. Lots of people in tech know them.
Sure, the online IDE.
Exactly. And they're introducing something they call dynamic intelligence for their coding agent tool.
Okay.
And this isn't just a minor update, apparently. It's really about making the AI more aware of context, better at reasoning, and capable of autonomous goal-driven behavior. They've added 3 key capabilities.
All right, what are they?
First, extended thinking. This basically tells the agent to slow down and think more deeply.
Ah, okay. So less rushing, more thoroughness.
Precisely. It produces more thorough solutions, even shows its step-by-step reasoning. You can enable this for complex stuff or, when you're stuck debugging something tricky.
Makes sense.
Second, there's a high-power model mode. This just uses a more capable AI model underneath for better accuracy.
So for the really heavy lifting.
Yeah, think like app performance optimization, major UI redesigns, complex database changes, integrating tricky third-party APIs, that kind of thing.
Got it.
And third, web search. This is on by default. Lets the agent search the internet for up-to-date info. You can also specifically prompt it, like use web search if you need to.
Which is pretty crucial, right, for real-world problems.
Absolutely. So these features together, they're designed to help you turn ideas into working apps more easily, tackling more challenging, maybe ambiguous problems.
Okay, so if we zoom out a bit, Replit's work here, it really highlights this trend towards more autonomous, more intelligent AI agents. And that brings up a big question. How are these agents actually being trained to get these capabilities?
Yes.
Especially in something as complex as software engineering.
Right. And this is where it gets really interesting, I think. Our sources also bring us details on something called DeepSWE-Preview. It's a state-of-the-art coding agent.
Okay, DeepSWE.
Yeah, developed through a joint collaboration, Agentic team, and Together AI. And what's really groundbreaking about this one is that it's trained solely with reinforcement learning, RL.
Just RL. No, like human examples.
Exactly. Using the Qwen332B model, which is an open weight model, importantly, not trained from human demonstrations or some secret proprietary model.
Wow, okay. And the Qwen332B, that's a pretty capable open model, right?
Yeah, exactly. It's the base brain, so to speak.
And how does it perform? That's the key question with RL sometimes.
Well, that's the remarkable part. DeepSWE-Preview gets an impressive 59% on something called SWE Bench Verified with test time scaling.
Okay, unpacks SW Bench Verified for us.
It's basically a benchmark that measures how well coding agents can solve real software engineering tasks, bugs, feature requests from actual GitHub repositories.
Right, real world stuff. So 59% is good.
It's considered state-of-the-art for open-weight coding agents. It hits 42.2% pass at 1.
Meaning it solves it correctly on the first try almost half the time.
Yeah. And 71.0% pass at 16. So it gets over 70% right within 16 tries. And crucially, they've open-sourced everything.
Everything, like the data, the code.
The data set, code, training logs, evaluation logs, the whole package. They say it's to democratize progress.
That is huge. Okay, so let's dig into the RL part. How does that work for coding? How does it learn?
Yeah, tell us more about that.
Sure. So in reinforcement learning, you have an agent. It takes actions in an environment, and it gets feedback, observations, and rewards.
Okay.
For software engineering, the environment is like resolving a GitHub issue or implementing a feature. The agent interacts with a simulated IDE.
Like a virtual coding workspace.
Yes, exactly. Terminal file system using tools like bash commands, file search, a file editor. And it gets a reward, a positive one, if the code it writes passes all the tests for that task.
And if it fails?
0 reward. Or if it just runs out of time. Simple feedback loop, essentially. Pass or fail.
Okay. And DeepSWE was trained on how many tasks?
It was trained on 4,500 real-world tasks from these R2E gym training environments. And get this, it ran for 6 days straight on 64 H100 GPUs.
Wow, 64 H100s for 6 days. That's a lot of compute.
That's a serious amount of compute. Those H100s are the high-end chips, specifically for this kind of massive AI training.
Training that at scale must have had its challenges, right? Just coordinating all that.
Oh, absolutely. A major hurdle they mentioned was just scaling up the environments themselves, the SWE bench ones, trying to run thousands of parallel Docker containers.
Docker containers, those isolated software packages.
Yeah. It apparently just overloaded Docker's API server. They couldn't handle that many simultaneous requests.
So how did they fix that?
They switched to using Kubernetes. They integrated Kubernetes support into their R2E gym framework.
Ah, Kubernetes for managing containers at scale.
Exactly. It let them dynamically scale across a whole pool of nodes, even beyond 1,000 CPU cores. And they used preloaded images to speed up the startup time for each environment. This elastic setup was key to reliably collecting the millions of interaction trajectories, the sequences of actions and results needed for the RL training.
Okay, makes sense. And the training algorithm itself, any innovations there?
Yeah, they used an enhanced algorithm called GRPO++ERGI, which is a more advanced optimization method. It includes several tweaks for stable training and better performance. One interesting technique was something called compact filtering.
Compact filtering, what does that do?
It basically masks out, or ignores, training trajectories where the agent hits the maximum context length or runs out of time or just gives up after too many steps without submitting a solution.
And why is that important? How does ignoring those help?
It helps prevent something called reward collapse by making sure the reward signal is only strong when the agent deliberately submits a solution it thinks will work. It encourages the agent to be more rigorous, to do more internal testing before submitting.
Ah, so it learns to be more confident, more careful.
Precisely. And surprisingly, it also led to less thinking per step. The agent didn't write these super long-winded thoughts for every single action.
Oh, interesting.
Instead, it seemed to encourage the AI to spread its reasoning out, long form, across multiple steps of the task. They saw the average response length go down, but the average number of steps taken per task went up.
So it's thinking less at each tiny step, but more effectively across the whole problem-solving process.
That seems to be the interpretation, yeah.
Yeah.
It's kind of thinking more strategically over the longer term of the task.
That's genuinely fascinating, like an emergent strategic behavior just from the RL setup. Did they notice any other interesting behaviors it learned?
They did. They found this pure RL training, without explicit instructions, led it to automatically learn some really useful things. For instance, it consistently learned to think about edge cases and repository regression tests when fixing bugs.
Okay, so checking if its fix breaks anything else.
Exactly. A really crucial part of good software development that it just picked up. Also, it adaptively used more thinking tokens, the internal processing units, for complex steps.
Like figuring out the root cause of a bug.
Right. It might use, say, 2,000 tokens for that. But for simpler things, like just scrolling through a file or running a quick script, it would use maybe only 100 or 200 tokens. Very efficient.
That adaptive resource use is pretty smart. So the big takeaway here isn't just that AI can code better, it's that this pure RL approach can actually foster strategic thinking, problem solving, beyond just pattern matching.
Yeah, it challenges maybe some assumptions about needing human demonstrations for complex reasoning.
And points towards a future where these AI assistants are less like autocomplete and more like autonomous collaborators. Plus, the open source aspect of DeepSWE is huge for getting this tech out there.
Absolutely. Democratizing access is key.
Okay, so we have these incredibly sophisticated AI models getting better and better, but this capability, this autonomy, it doesn't exist in a vacuum, right? It needs power, lots of it.
A lot of power. And that brings us to the physical footprint, the hidden cost.
Exactly. While the models are digital, powering them has a very real, very physical impact, which leads us to this situation with xAI, Elon Musk's AI company, and their data center project near Memphis.
But the natural gas turbine story.
Yeah. So recent reports say county regulators granted xAI permits to operate 15 natural gas turbines, capable of generating up to 247 megawatts. That's a significant amount of power.
It is. But there's more to it, wasn't there? The backstory.
There is. The Southern Environmental Law Center, the SELC, they stated that xAI had apparently already been operating as many as 35 generators.
Without permit.
Without permits, yeah. Collectively capable of producing up to 421 megawatts.
Wow, okay. That definitely raises some serious questions about, the environmental side of scaling AI infrastructure this quickly.
For sure. And the SELC has actually threatened to sue xAI for alleged violations of the Clean Air Act. They're representing the NAACP on this. And they're highlighting the really substantial amounts of pollution that are allowed under this new permit, even the permitted amount.
So what kind of pollution are we talking about? What are the numbers?
The permit allows for pretty significant annual emissions calculated on a rolling 12-month basis. We're looking at 87 tons of NOx, which forms smog,
Yeah.
0.94 tons of carbon monoxide, 85 tons of volatile organic compounds, 73 tons of particulate pollution.
Particulates are a big health concern.
Right, and nearly 14 tons of hazardous air pollutants. And notably, within that, 9.8 tons of formaldehyde.
Formaldehyde, which is a known carcinogen.
Yes, and xAI is required to basically self-report to keep its own emissions records.
Right. So how did the local community react to all this? Were they involved?
Well, there was definite concern. A Memphis community group actually offered $250,000, $250,000, for an independent air quality study before the permit was issued.
That shows pretty strong local feeling.
It does. The city of Memphis did perform its own air quality testing back in June, but the SELC raised several issues with those tests. So questions remain about the validity of those tests.
And, this isn't just about xAI or Memphis. This is kind of a microcosm of a much bigger global issue, right?
Absolutely.
The massive energy demands of AI data centers everywhere. Google, Amazon, Microsoft. They're all grappling with this, the power consumption, the water usage for cooling.
Yeah, I saw some estimates suggesting AI's electricity use could rival entire countries within a few years.
Exactly. It forces this recalculation of energy needs and where that energy comes from. It's not just local pollution. It's a global energy challenge tied directly to AI's growth.
So this Memphis situation, it really throws into sharp relief these growing environmental concerns. It's a stark reminder, isn't it, that the digital advances we celebrate have these very tangible, very physical consequences.
Yeah, consequences that affect local communities, the environment, our energy grids.
It forces us to confront that hidden cost of progress. As AI gets more powerful, we have to think really hard about how we power it responsibly.
It's a critical piece of the puzzle.
Okay, so from building the AI to powering it, let's shift gears now to governing it. How are we trying to manage all this? And that brings us to the European Union.
Right, the EU AI Act. They've really tried to position themselves as leaders in AI regulation.
They have. And what's really compelling here, based on our sources, is how they're sticking to their implementation schedule for the act, despite some pretty significant pushback.
Yeah, industry pressure hasn't seemed to sway them much.
Not according to this. Over 100 tech companies globally, including huge names like Alphabet, Meta, Mistral AI, even ASML, the chip equipment maker.
Big players.
They've apparently been urging the European Commission to delay the rollout. Their argument is basically that the AI Act will hurt Europe's competitiveness in the AI race.
It's the classic innovation versus regulation debate, isn't it?
Pretty much. But the EU's stance seems unwavering. The European Commission spokesperson, Thomas Regnier, was quoted being very clear. He said, there is no stop the clock, there is no grace period, there is no pause.
Wow. That's pretty definitive language. No ambiguity there. It signals a really strong resolve to prioritize getting these regulations in place.
It really does. So can you give us a quick refresher? What's the core idea behind the EU AI Act? What does it actually do?
Sure. Fundamentally, it's a risk-based approach to regulating AI applications.
Risk-based.
Yeah. So it outright bans a small number of what it calls unacceptable risk uses. Things like cognitive behavioral manipulation, social scoring by governments, stuff deemed just too dangerous.
Right, the really dystopian scenario.
Exactly. Then it defines a category of high-risk uses. This is where things like biometrics, facial recognition in many contexts, or AI used in critical areas like education, employment, law enforcement, credit scoring, that all falls in here.
And what are the requirements for those high-risk systems?
Developers of those systems will need to register them in an EU database and meet pretty stringent obligations around risk management, data quality, transparency, human oversight, and cybersecurity to be allowed onto the EU market.
Okay, so significant compliance hurdles there.
Definitely. And then for lower risk things like maybe a simple chatbot, it calls those limited risk. The main requirement there is transparency, basically. You need to make it clear to users that they're interacting with an AI.
So it's tiered based on potential harm.
Exactly. Now, the complexity, of course, is in drawing those lines and balancing innovation with safety. Industry argues it might be too restrictive, stifle development. The EU argues that clear rules actually foster trust and encourage responsible innovation in the long run.
It's a huge undertaking to implement, though, right? Across all those sectors.
Oh, absolutely.
Sure.
It requires developing technical standards, setting up auditing processes, enforcement mechanisms. It's a massive regulatory build-out.
And the timeline. When do these rules fully kick in?
They started rolling it out in stages last year, but the full set of rules is expected to be enforced by mid-2026. So companies have some time, but the clock is ticking.
Right. So for you, the listener, the EU AI Act is really more than just European legislation. It's a major global benchmark for AI governance.
It really is. It's trying to set standards for safety, transparency, ethics.
And its firm stance, even with industry pushback, sends a strong signal globally. It's likely to influence regulations elsewhere.
Definitely. It forces this crucial conversation. How do we balance the incredible potential of AI with the need for safeguards? Can regulation actually help guide innovation responsibly, or does it inevitably slow it down too much?
That's the billion-dollar question, isn't it?
It really is.
Wow. Okay, what a deep dive today. We've covered a lot of ground. From these incredible leaps in AI's ability to code, to think strategically.
Almost autonomously now, in some cases.
Then through the very real, sometimes messy environmental impacts of just powering these things.
The hidden physical costs.
Right. All the way to these critical, complex, global efforts to actually regulate AI's development and use.
And if you step back and connect those dots, it's just so clear that the future of AI isn't just about the tech itself. It's not just about faster models or more capability.
It's much broader.
It's equally about how we manage the resources it consumes physically, environmentally, and how we thoughtfully craft policies. That whole balancing act between innovation and safety, ethics, societal well-being.
These three areas we looked at, the cutting-edge code generation like DeepSWE, the energy demands highlighted by the xAI situation, and the comprehensive legislation like the EU AI Act. They might seem distinct, but they're so profoundly interconnected, aren't they?
Inextricably linked. You push forward on AI capability, it increases the energy demand. That demand raises environmental and resource questions, which then fuels the push for regulation and governance.
Which in turn might shape how the next generation of AI is developed. It's a cycle.
Exactly. It's a dynamic interplay. Each development in one area sends ripples through the others.
So maybe a final thought for you, the listener, to mull over as AI keeps evolving at this breakneck speed.
Yeah, consider this. As we keep pushing for more powerful, more autonomous AI, and as the demand for energy to fuel them keeps growing, and as these global regulatory frameworks get more defined, how might all these forces interacting ultimately reshape the entire landscape of technological innovation?
Right. Not just AI, but innovation itself. And what could that mean for our daily lives, say, 5, 10 years down the road?
It's a big question with no easy answers. Something to keep thinking about.